Hello everyone. In this hackathon, we are trying to demonstrate a control plane protocol called Mpbgp over the VXLAN. As you already know, we have a VXLAN overlay feature that already comes with the benefits such as it can traverse any workload across any layer 3 boundaries, scale up to 16 million segments, and it can provide traffic and address isolation. So what is this missing link we are talking about today? The current feature has limited scalability, it has layer centralized, and it is very admin dependent. Yes, it's a big barrier when it comes to the implementations in big data centers and cloud deployments. So in this hackathon, what we are trying to achieve is the following benefits that will be getting by implementing the BGP VPN control plane over the VXLAN, such as optimize or eliminate flooding of broadcast unknown multicast traffic, virtual machine mobility, and due to decentralized VTEPs, we need not face any hairpinning of the traffic. It also supports large-scale multi-tenancy, route filtering with the help of route targets, and ingress replication of multi-destination traffic, and also it gives freedom from the multicast underlay. Yes, it's a wow factor, but we needed to tweak much more than NetScaler, not a NetScaler alone, but much more than NetScaler, that is a mass. So for the first time, we are deploying a control plane over the mass. Now let's start the demo. In this demo, we are trying to configure a service from the mass to the NetScaler. Also, the mass will push the address and the MAC reachability to the peer BGP route reflector. This route reflector in turn will push these informations to all the VTEPs or the hypervisors that are listening to this BGP update. That's how all the VTEPs or the endpoints will become aware of the endpoint reachability with the Mpbgp control plane protocol. Now let's configure the service on the NetScaler using mass. Okay, now let's see. So we have configured a new service called service new, which is currently down. Let's see the op table and then grep for this for any entry. Now let's try to push the VTEP IP MAC route target details of the NetScaler to the peer route reflector from the mass. Okay, now let's try to bring up the service on one of the Ubuntu servers. So this server will also run a backpipe BGP process. Also, we have turned on the debugs on the BGP route reflector. Okay, let's see. So here we can see that the route reflector is advertising the update with the MAC, with the IP of the service, the label, the gateway, and the route targets, and with the VA9 ID 121 with lookup differences 100. So let's see, the service has come up on the NetScaler. Yes, here it is. The service is up. Now let's check the ARP entry for the 21.3 host. Yes, as you can see, this entry is now populated. Now let's try to bring down the service from the VTAP. Okay, let's see the BGP update. Yeah, here it is. See that the delete route update from the BGP route reflector. So let's go to the Netscaler and check the service. Yes, service has gone down. Now grab for the ARP entry. Now the ARP entry is been deleted. So please take a note that here the ARP table has been modified to include the VXLAN information, the VTEP information, and the origin of this entry, that is from the control plane Mpbgp. As we saw, there is no need of tunnel now with the VXLAN configuration, or we need to run any BGP process over the Netscaler. So from this hackathon, what the changes we have done or hacks we have done are, we have introduced a new control plane protocol called Backpipe BGP. This is the protocol that is used in OpenStack Neutron. Apparently, this is the first control protocol introduced on the mass. Also, we have written a data plane driver for the Netscaler to convert the IP and MAC reachability information into the network calls. Then we have tweaked the backpipe BGP code such that we will create a unique VPN instance for every admin partition on the Netscaler. And finally, on the mass, we have introduced a new term called route target that uniquely identifies the admin partition for multi-tenancy. Now let's see the changes done on the Netscaler in this hack. Firstly, we have modified the ARP table and introduced new entry called the control plane. So this entry is non-persistence, that is, it goes after the reboot but doesn't timeout. That's it from Sharwari and myself. That's Praveen. Thanks for your time and thanks for watching.